Good morning. Welcome to the Driller Newscast, episode 21. I'm your host, Brock Yordy, and this week in the news, we cover OSHA's statement on 22 trench fatalities in the first 6 months of 2022. Our featured story of the week will be part 2 of my discussion with Garen Ewbank of Ewbank Geotesting. In the second half, we talk about drilling methods, PDC bits, and the future of ground source geothermal. It's all very exciting. But before we jump into the news and our featured story, let's talk safety. For this week's safety topic, we're going back to trenches. Trenching standards require protective systems on trenches deeper than 5 feet and soil and other materials kept at least 2 feet from the edge of a trench. Additionally, trenches must be inspected by a knowledgeable person, be free of standing water and atmospheric hazards, and have a means of safe entering and exiting prior to allowing a worker to enter. Do you know the 3 types of soils? We have type A, B, and C. A being the most stable with a compressive strength of 1.5 tons per square foot or greater. These soil types are clay, silty clay, sandy clay, and clay loam. Remember, soil cannot be classified as a type A if it is fissured or if it has been previously disrupted, if it has water seeping through it, or it is subject to vibration from sources such as heavy traffic or pile drivers. So next we jump into B, which is not as stable as A, but better than C. Type B soils are often cracked or been disrupted, have pieces that don't stick together as well as type A soil. Type B soil has a medium, unconfined compressive strength between 0.5 and 1.5 tons per square foot. Examples of type B soils include angular gravel, silt loam, and soils that are fissured or near sources of vibration but could otherwise be type A. Then we jump to type C, which we work a lot in. Type C soils are the least stable type of soil. Type C includes granular soils in which particles don't stick together and cohesive soils with a low unconfined compressive strength of 0.5 ton per square foot or less. Examples of these soils are sands and gravels. Because it is not stable, soil with water seeping through it is also automatically classified as type C soil, regardless of its characteristics. We have to be safe out there and just remember the 3 S's: slope, shore, and shield. We got to do better than what's happening right now in the construction industry with trench fatalities. Be safe. For this week in the news, we're going to talk about what's impacting the drilling and construction industry more than anything else. And that's 22 individuals' lives taken away from us to trench fatalities. And here's a statement from OSHA released on July 14th, 2022. In 2022, the first 6 months, 22 workers have fallen victim to the deadly hazards presented in trenching and excavation work, surpassing 15 in all of 2021, and prompting the U.S. Department of Labor's Occupational Safety and Health Administration to launch enhanced enforcement initiatives to protect workers from known industry hazards. To stress the dangers of disregarding federal workplace safety requirements for trenching and excavation work, OSHA enforcement staff will consider every available tool at the agency's disposal. These actions will place additional emphasis on how agency officials evaluate penalties for trenching and excavation-related incidents, including criminal referrals for federal or state prosecution to hold employers and others accountable when their actions or inactions kill workers or put their lives at risk, in keeping with its national emphasis program for excavation. OSHA compliance officers will perform more than 1,000 trench inspections nationwide, where they may stop by and inspect any excavation site during their daily duties. We're seeing criminal actions taken in Massachusetts, Texas, Oregon, Washington, Florida, where once the OSHA investigation is done and those penalty and fines have been handed out, criminal investigations start with owners and supervisors and foremen going to prison. On with the OSHA statement. OSHA is calling on all employers engaged in trenching and excavation activities to act immediately to ensure that required protection are fully in place every single time their employees step down into or work near a trench. This is from Assistant Secretary for OSHA, Doug Parker. In a matter of seconds, workers can be crushed and buried under thousands of pounds of soil and rock in unsafe trenches. The alarming increase in the number of workers needlessly dying and suffering in serious injuries in trenching incidents must be stopped. Every one of these tragedies could have been prevented had employers complied with OSHA standards, Parker continued. There simply is no excuse for ignoring safety requirements to prevent trench collapse and cave-ins and leaving family, friends, and coworkers to grieve when the solutions are so well understood. June 28th was the last situation where a 20-year-old and a 39-year-old died in a 20-foot trench collapse where trench shields, which could have saved their life, sat unused besides the excavation. In April, in West Michigan, two brothers died, 68 years old and 59 years old, in a 14-foot deep trench. They were digging for a drainage for a pole barn. We can do better than this. We understand as an industry what the standards are, and you can see OSHA is in full enforcement to protect. But this is a very serious situation, and we as an industry can do better with slope, shore, shield, getting the right engineering components in place, understanding that there is no time that is worth jumping down there just for a minute. And we're looking at these trench collapse of 14 feet and 20 feet where it's taking 8 to 10 hours to recover the bodies. This is an awful situation, and we can do better as an industry. For our featured story of the week, we're going to go to part 2 of my discussion with Garen Ewbank. Garen designed drill rigs. His family has been drilling water wells in Oklahoma since the early 1930s, the same time that George E. Failing created the first portable drill rig. He has been a major pioneer and promoter of the ground source geothermal industry, and we're going to talk about drilling methods, PDC bits, advice for the next generation, and what is really exciting that is coming up in geothermal. I hope you enjoy.
I've done nearly all types of drilling myself personally. I've done straight circulation, reverse circulation, a lot of reverse circulation actually, down the hole hammer, dual stem, foam, recirculating foam, particularly in lost circulation deals. And I used to use the Johnson handbook. I don't know if anybody still has those.
Oh, it's the Bible. Yep.
It's the Bible, man. And if you'll get into that thing, you can learn a lot of stuff to take care of some of the issues you get into. And once you get into those, you call your mud people and say, help. Okay. And they'll do it. And one of the first things they're going to say is, what's the pH of your fluid? It's simple, but we have to go through a very step process. It's not hard. These drillers listen to this, know exactly what I'm saying.
I always say if you grab that Johnson Groundwater and Wells book and you can dog ear 20 pages, you'll be a competent driller. If you can dog ear 50 pages that you refer to time to time, you're going to be a good driller. And if you're 100 plus pages that right now, mine has notes sticking out of it all over the place and things, Tom Hanna has told me after the fact and whatnot. And I always say it's the mentors and the resources they've told me to go look for that have allowed me to be successful.
Yeah, the professor from Ohio State University that wrote all that stuff, I've met him, talked with him, but you got me thinking, you didn't steal my book, did you, with all those marks? I have about like that.
Yeah, folks, you can find that on eBay. And, I'll say it's the Ewbank's original Groundwater and Wells. I think if you can find a first edition right now, it's, it goes for some pretty good cash.
So. Yeah. Yeah, I'd like to have one. Anybody out there?
And we've challenged those guys. When is the fourth edition? You know, we've got a lot of good things that have come out since the
Yep.
third, and I know they're working on it. It's just we're a tribal industry, and we don't write things down as well as we should. We got it
No,
in the field.
no, you're right about that, Brock. And that's why on that borehole research project, I ran those sweet logs, is because I wanted to document what was actually happening and figure it out from there. So, and that worked out really well. Okay.
You know, we need us as drillers to embrace the science, and we need the science community to embrace that being muddy standing on the back of that platform is the reason why I know to pull up and
Yeah.
slow down rotation and take a moment to see what's going on before I
Yeah.
plant rods.
That's interesting that you mentioned that because uh, in the middle 90s, I worked with Sandia National Labs while they were developing the PDC inserts for this new type of bit. My intent was to get something I could drill the same rate as a down the hole hammer with a fifth of horsepower. Okay, that's where I was trying to head. And with today's diesel prices, that may make a difference. But anyway, we looked at a whole genre of stuff. Amico Production had a research facility in Tulsa, Oklahoma, that they were getting ready to close down. And I called them and I said, could we take that stuff out to Sandia Labs? They said, haul off all the stuff you want to. And we did. I think it was like, I don't know, 10 or 14 semi-trailer loads of stuff. And
The
just,
first phase of Ball State, Triton Geothermal got their hands on some PDC NTEC bits. And at the time, instead of it polycrystalline diamond compact, we were calling them pretty darn costly bits, for PDC. But you're saying in the 90s you're looking at PDC. That is exactly our industrial drilling right there. We have
yes.
advancements happening,
Yeah.
but
Yeah.
it still takes us 20 years to be comfortable enough to say we're going to try this.
It has. And what I learned in all of the experience on, I don't know how many thousands, millions of feet of ground heat exchangers, is if you treat those PDCs correctly, you can get a lot of life out of them. Okay. Just don't let them chatter. So, uh, really, when it comes down to it, you'll get a lot longer bit life than if you're using say a Reed FP62 with a long finger button on it and something like that. Those are good. They were good journal bits. Okay. But we needed something better because I needed to get more than 3,000 feet out of a bit. I need to get 100,000.
I believe there's two things that happen with PDCs that we waver on as an industry. One is there are some that come from non-accredited bit manufacturers outside of the United States that maybe were at a conference and
Yeah.
set a pack of cigarettes next to them, took a photo and went back and 3D printed something. And I think the other aspect is, again, back to the science. If you talk to our oil field brethren or our mining brethren and ask them how they were doing it, they would say it's weight on bit. And we go, okay, yeah, we got all the pull down in the world. And they're going, no, no, no.
No, no,
Bottom
no.
hole assembly, my friend. It's about proper rotation and
Yep.
having actual collars so that we don't have that chatter. And then we can start to make hole.
Exactly. And thank you for bringing that point to bear because that's exactly what you've got to do. Okay. If you do that right, man, those PDCs will last a long, long time and they'll make you a lot of money. And that's what we want. You know, a guy that's drilling a ground heat exchanger, he gets paid not when he TDs, but when the loop's in and the borehole's grouted. That's what he's after. And so we want him to be turning to the right, get onto the next borehole, make you some more money. That's the whole, end game to what we're trying to do. And, rack up that footage with the loop in it and grout it as quick as you can, but as accurately as you can. And that requires us to really maintain the properties of the circulating fluid, whether it's air or water. Okay.
Couldn't agree more. So you said you became a trainer with IGSBA in 1990, and IGSBA started in 1986.
Yeah.
How long have you been working with the folks at IGSBA?
Uh, well, I with Oklahoma State when I graduated, and that was in '72. Okay, but that was in other areas. But IGSBA, probably '94 on is when I really got involved with it, particularly because of the thermal conductivity testing. I had to get professional engineers to size these things. Okay, and I recognize that. But along at the same time, uh, we had to have good design software to where we could take the building loads, go through the energy loads, and then go into the ground loads to properly size the ground to meet those other two. And so it was kind of fortuitous. I was working with OG&E, not for them, with them. And we sent Dr. Jeffrey Spittler up to train because we knew if they did economic analysis on how much it costs to run these systems, then we could get the loads, okay, from the heat pumps, those thermal loads. We sent Jeff up there in the OG&E corporate jet, and he was, I think that was really great, and it was. Okay, he thought he would be there a week. He came back the next day, they had it solved. Train jumped all over them. They're like, yeah. And so that is the other side of it to get the facility loads to match up to the ground heat exchanger design. All right. And Dr. Spittler did a great job. I mean, of course, he's a brilliant guy. So we knew he would do a good job at it. So kind of answers your question, but not totally.
It's hard to fathom when you look at the age of geothermal in the United States versus the rest of the heating and cooling capabilities we've had, or even, globally. I can see where many people are still pulling from the 1960s civil engineering playbook and saying, so what, prove it.
Yeah. Well, we have systems that's been in for a very long time that are operating very well and very efficiently. The proof is in the pudding. Okay. And if you'll look at what the EIA says and the EPA says, these are the most efficient, longest lasting heating and cooling systems that exist. All right. So we're no longer into a makeup, promote something new, something different. This is the real deal. Okay. And that's why beneficial electrification and ground source marry up so well together. They will. And, just look at areas where we've got gas constraints. And they have a lot of those, by the way, because they have old pipelines. They can't raise the pressure to put more gas through. If they do, they'll blow up some more homes like Merrimack Valley and things like that. And so, let them back off, let them do their deal and come in and do some of these things. And I really don't care if they do it a house at a time or do a district system. Okay. That should be up to that utility, particularly in New York, that can now do that. And that's really a good thing. Okay. So that begins, I think, the march of our industry towards scalability, which we did not have before.
It's a great time to be part of this industry.
It is. It is.
What are you most excited about with geothermal right now?
Polymodal heat pumps. Okay.
Educate us.
Okay. Well, we have air source heat pumps, and then we have cold climate air source heat pumps that they say can, heat your house when it gets down to minus 22. Well, you can if you put a condenser outside that's like 4 times the size. I'm passive house trained also. And one of the things that we would do on passive houses is if we had a load of X, we would get a unit outside that was 2X, okay, twice the capacity. So it can meet those lower loads. That's what a cold climate heat pump does. Okay. You can do refrigerant injection, a whole bunch of other things. And if I get too complicated here, stop me, Brock. Okay. There's just a lot of ways to do that. But refrigerant circuits with the refrigerants we have today, right, have limits. We can't go past that. All right. So we're not going to see a big increase in the boxes. The units that go in themselves, either residentially or commercially, you're not going to see a giant movement in efficiency unless we have a new technology on heat transfer. And right now, I was taught that hot flows to less hot. Okay. So that's our boundaries. And so we get back into those, Fourier's laws and things like that. But if we understand how the ground works and thermally how that happens and how it stores heat, then we can discharge that thermal battery as needed. Okay. So we can let it move the heat. Okay. That's conductivity. Store some of it and then call back that storage later at another day, or keep it there for winter, or get rid of it. I mean, you got a lot of ways to do it, but it gives you the time of use portion that we didn't have before. And that's really important today.
It's just neat to see the innovation or we have a priority. So we're now looking at how we can do things differently and, push and promote. And that would be my last question. If I was talking to a 19, 20-year-old young man or woman that's considering different industries to get into, what would be your elevator pitch to them to come into the geothermal industry as an engineer or as a drilling company or a scientist?
Okay. Academically, okay, beneficial application is going to drive these systems to the forefront. So there's just going to be tons and tons of work. There are not a lot of off-the-shelf designs you can pull out. So you're going to have to know and learn this knowledge. It's different, all right, because that ground heat exchanger or that thermal loop coupling is something that has to be designed. All right, you have to know those things. NREL, excuse me, I use acronyms all the time. I apologize for that. Okay. The National Renewable Energy Labs and Rocky Mountain Institute and a number of people have been working on what does this look like when we connect community loops together? Well, we're finding that these energy commons operate completely different than a single building. All right. There's a big portion of diversity. And actually, as we get into high density mixed use, we find that the heating and cooling loads are about balanced. Oh, now that really starts shortening the ground heat exchanger. Okay. And so the annual change between heating and cooling kind of goes away as we go out to the low density residential, a house out by itself. Okay. That's a different deal. It has to be designed for its big block heating and cooling loads. Right. By the way, do you know where have you ever heard the deal 200 feet per installed ton?
When I first started, most people in the Midwest were using 150 feet per ton. But, we have 20 feet to water, 5 feet to water.
Okay, yeah. Where the 200 feet per ton came from was a 1,500 square foot house in Stillwater, Oklahoma, 1970s construction with 3 people living in it facing south. All right. The heating load and the cooling load were different. The cooling load was 37,000 BTUs per hour at peak. The heating load was 55,000 BTUs per hour at peak. So they would put in a system that satisfied the cooling load, 200 or the 37,000 BTUs, and they would use supplemental heat for the additional portion on the heating that the ground heat exchanger couldn't provide. With thermal conductivity of 1.6 of Stillwater, the deep earth temperature about 63, that's 200 feet per ton. That's where it came from. And people grab the deals. The loads on the facility, I don't know if that ton of HVAC runs 1 hour or 8,760 hours. And the load of the ground heat exchanger is enormously different. That's why the loads is really important. And we've got a really good way that even on retrofits, very quickly you can go through and figure out what the load on that house is for heating and cooling with the outside air temperature. It's conductive load. It's pretty straightforward residentially. Commercially, it's quite a bit different, but it's easy to do. You can do a spreadsheet. They're free. You can download them and get them. And, in 10 minutes, you got your answer. Okay. So it's not that complicated. And I wish more HVAC installers would use that. All right.
So for a aspiring individual coming in,
Oh, okay.
get your get your civil engineering degree, get some geoscience background, and then find a good company to intern or work with to learn
Yeah,
design build.
I don't care if it's civil, mechanical, industrial, or geology, or any of those degrees. That shows you know the sciences, okay? And then, if you like to work outside, hey, that geologist and the drilling side of it's pretty fun. I mean, it is a lot of fun. I got to tell you, you get mud in your blood and you can't get it out, right? Okay. And I walk in little circles, turning to the right when I go down the street. But anyway, they could do that. And there is just going to be an enormous demand. The engineering companies I'm working with throughout the United States, all of them have hiring needs right now. Right now. The drilling contractors I'm working with, they have needs for hands, okay, at all levels. Okay. One of the issues is that when we go out to that site, we're a new trade. All right. And the thing about it is when that electrician comes out in his truck, he might have $80,000 in it, right? When that drilling contractor drives out to that site, he may have $1 million in the thing or more. Right. So they're the highest capitalized group out there per employee, and they need to be paid for that. And that's what we're trying to do. The idea of reducing the amount of the ground heat exchanger is to be able to pay them more money for what they do. That's the whole idea. Okay. And we might get there actually, which would be a good deal. I'd like to see that. I'd like to see the guy make the same amount of money working half as hard, wouldn't you?
Absolutely.
And we're headed there. That can happen.
I think that's a beautiful place to wrap this up.
Okay.
I appreciate your time today, and I know you said you had some gigs going on. The newscast wasn't one of those paying gigs. Garen donated his time to come on, and we really appreciate that because every time I'm somewhere that I can listen to this man talk, maybe I only get 70% of it, but I know this industry is as important as providing water. And with climate change and net zero initiatives, and I have a 4 and a 6-year-old. And today we were talking, and my daughter goes, "When will I be 30?" And I go, "Well, in 24 years." And she goes, "Do you think this place is going to look the same?" And I said, "I hope it's still green trees and we're able to, be out in the backyard on the swing enjoying this, and we're not, looking at extreme temperature swings and big storms and bad stuff." So this is why geothermal is as
Real,
critical to electrification and everything.
I've got a real quick story for you, Brock. About 3 years ago, one of my partners was in Australia, and it was January, and it was really hot, having a terrible heat wave. Power systems were going down everywhere. I can't remember now how many megawatts of production capacity they had. They lost because the grid was way overloaded. At the same time, a buddy of mine in Indiana sent me a snapshot of his system during a polar vortex the same darn day. It was minus 16 out and a wind chill of like a minus 30. And he said, "My heat pump thinks it's 46 degrees outside."
Because of our ambient temperature of the ground.
Yep, yep, yep. And there he had driven it down from about 54 degrees to the low 40s, doing really well. And so with that, that's all about efficiency. It's all about the lift of the temperatures that we're going to do between the space and the refrigerants and the source and the sink. That's just the math. It's easy to do. We're getting there. We've probably got the brightest industry of anybody out there, to be honest with you. I just see a really bright future. We need more hands turning to the right. Hopefully they don't have to shovel mud so much. Get them a good mud cleaning system to keep that mud system in check as they're drilling. I know that's a lot of stuff to haul around, but as we do those things, we'll increase our productivity and lower our cost. And I encourage everybody to try to go down that road.
And it is July right now, but in December at the National Groundwater Association, IGSPA will be going on at the same time and a few
Yep.
days earlier. So if you are a water well driller that is curious, get signed up. Come be part of IGSPA. It's just as important as NGWA.
Yep.
And learn this and diversify. And maybe you got that 22-year-old son or daughter, and you're that late 40s father, and they're just chomping at the bit to do something, and you don't want to get off the platform. Let them
Yeah.
get on a platform and drill some geothermal and do some good for that industry.
Yeah. And do some good as we go forward for the next 30 years. And we really deliver that better than any other technology out there, because ground source is always there, always available. When the wind's blowing or they're not blowing, or when the sun's shining, when it's not shining, we're there. All right. And so that has to be what everybody's going to hang their hat on for heating and cooling in the future, which is 40% of the load of our electrical system.
And that's huge.
Yeah, it is. We're talking quadrillions of BTUs. It's a big number.
It is. Thanks again, Garen. This has been an excellent conversation, and I know we talked drilling and we got technical and we talked about the future and the benefits, and I couldn't ask for a better conversation than you going with us today.
Well, that's great. I'm standing on the shoulders, though, of some people that really did some good product, both in the engineering and design and out in the field. I'm telling you, I learned more from some of these old shot hole drillers than anybody else out there. So, in parting, I'd like to tell all the drillers that are listening to this, get out there and keep turning to the right.
Yes, absolutely. Drilling progresses civilization from water to information to heating and
Yeah.
technology. Even the rare earth minerals we need to be able to do this 21st century
Yep.
goal of net zero all come from drilling. We progress where humanity goes next.
That's true.
Thanks, Garen.
Thank you, Brock. I enjoyed it.
Thank you for joining us for episode 21. A huge thanks to Garen Ewbank and all the great knowledge and inspiration he dropped on us. We have to be paying attention to trenching conditions and understanding there's no reason to jump into an unshielded or unprotected trench before we have it properly stabilized. Slope, shore, shield. It's Jubilee week. Come check out the Driller booth. Jeremy, Chelsea, and I will be there Sunday and Monday. You can catch me at Saturday classes where I'll be teaching on OSHA Focus 4, creating solids and disposal, and expectations for the 21st century new hire. 3 different classes there. And then you can always catch me on Sunday just before the Jubilee opens, where we will continue our game show, Who Wants to Be a Driller? And it's going to be exciting this year. Thanks for listening and watching. Have a great week.